In this video, we are going over the big ideas of the second chapter. In the textbook, there's actually an additional section which I moved to the third chapter because I think it flows better. But here are the big ideas for the second chapter. So really, we're talking about a line segment, okay? And whenever you see a line segment, you should really ask yourself three questions. What is its slope? What is the midpoint? And what is the length of that line segment? I mean, you might have even more questions than that, but in this course, really those three questions are very helpful. So we already know how to find the slope from grade 9, but what we don't know how to find is the midpoint of a line segment. So really try to understand where the formula came from. Try not to memorize it. So we had a little diagram to help us prove the midpoint of the midpoint of a line segment using congruent triangles. But really, the idea that really helps you with this formula is to find the halfway point. All you really want to do is average the numbers. Okay, so that's why you average the x values and average the y values, and you'll find the midpoint. Okay, what about length of a line segment? We really try not to memorize this formula. Where did it come from? It came from the Pythagorean theorem. Okay, the length of a line segment is really, or the line segment can really be visualized as the hypotenuse of a right triangle. Okay, the line segment can really be visualized as the hypotenuse of a right triangle, so that's why this formula is derived from the Pythagorean theorem. So this is the run and this is the rise. So if these are the lengths of the legs of the right triangle, it makes sense to see it as or say it as run squared plus rise squared, and then take that sum and square root it, and there's your hypotenuse. And then once you got comfortable with the length of a line segment, we actually use that to help us generate the equation of a circle. Okay, so this formula here is really coming from the length of the line segment. Okay, now because it's centered at the origin, in fact, the circle must be centered at the origin, otherwise this formula is going to be slightly different. So because it's centered at the origin, really it's a lot simpler. It's x minus 0 all squared plus y minus 0 all squared. But of course, x minus 0 is just x. Anyways, really try to relate the length of a line segment with the equation of a circle centered at the origin. Yeah, we just talked about the circle and the equation of a circle, and that's basically the whole unit.